interactive videos. I like to talk a lot about Zoom events, Zoom production, as well as in-person and virtual event production, and sometimes running your own business. If you also like more free content, give the Better Events podcast a listen. I co-hosted with fellow event pro. So we have a lot more free content.
Gente, me dice que api eso está rolando.
Yeah, good evening, everyone, and welcome to today's webinar hosted by the Nigerian Society for Biomedical and Clinical Engineering. The topic for today's webinar is automations and robotics in biomedical engineering. And my name is Oluwatoyin Olumurewa, and I'm honored to be your moderator for this exciting section. Our speaker here today, who is an expert, is going to share his insight on how automations and robotics are revolutionizing the field of biomedical engineering, driving innovation, and improving patient outcomes. Automation and robotics are transforming biomedical engineering in unprecedented ways, from surgical robots to automated diagnostic tools. These technologies are not only enhancing precision and efficiency, but also expanding the possibilities of patient care. And today, we're going to explore these advancements and discuss how they are shaping the future of healthcare. So before we start today's webinar, I have a few announcements to make. This webinar is being recorded. You may exit the webinar if you do not consent to the recording. The recording will be available on our YouTube channel, Nsbce Media, and you will have the opportunity to make comments and also to ask questions at the end of the presentation. And here are the webinar's rules. All participants are to mute their microphone and camera during presentation to avoid distractions. And kindly signify your intention to ask questions or contribute by raising your hand. So now permit me to introduce our distinguished speaker. His name is Mr. Eric Nkansa Boateng. He's a well-seasoned biomedical engineer with master's certification in robotics from the lovely Professional University, India. He's currently a manager in the Biomedical Engineering Department at the Universal Hospitals Group, which is a hospital engineering contracting firm that deals with turnkey healthcare projects and noted for modern infrastructure. Notably is the Bank of Ghana Hospital, Sewa Infectious Disease Center, just to mention a few. So in his free time, he loves to read and research on biomedical engineering innovations. So our distinguished speaker, Mr. Eric Nkansa Boateng, over to you, sir.
Good day. Good day, ladies and gentlemen.
Good day, sir.
I'm Eric Nsbce, and I'm an astute biomedical engineer with over a decade experience. And I am very, very grateful to be called upon to present on the topic, the applications of robotics and automations in biomedical engineering. Thank you. As I've been introduced by Lucci, I'm Eric Nsbce, and I have a first degree in biomedical engineering from the All Nations University in Ghana, and also possess a master's degree in engineering in robotics and controls from the Lavri Professional University in India. I have a decade of experience. I've worked with Ghana Health Service and other private medical equipment firms, and currently I'm the assistant manager in charge of planning and space planning at the Universal Hospitals Group, which is a turnkey hospital contracting firm in Ghana. Thank you. In my presentation, I'm going to touch on the father of biomedical robotics. I'm also going to touch on the future of robotics. I would see you through the definition of robotics and automations. Also, I'm going to feed upon the types of biomedical automations, the applications, and also the advantages of automations and robotics in biomedical engineering. Thank you. First on the slides, I would like to introduce Dr. Russell Taylor, who is the father of biomedical robotics. He is currently the head of the computer engineering at the Johns Hopkins University, and also the director for the laboratory for computational sensing and robotics at the Johns Hopkins University. He is known as the father of biomedical robotics. He invented the AML, that's the algebraic model language for streamlining and control of robotics and automation processes. He first of all worked with the IBM, that's the International Business and Machine Corporation, which was established in 1911. That's the world first, which built the world first surgical robot. That's the IBM, International Business Machines Corporation. So currently, he combined with the head of engineering for computer engineering and mechanical engineering, and also serves in the School of Medicine. So that's Dr. Russell Taylor, who is known as the founder for biomedical robotics. I would like to touch on the robotics past, present, and future. Currently running the healthcare industry involve numerous workflows, as we know, which strives from case management, patient wellness, remote and monitoring, and a whole lot. So manually managing all these workflows in biomedical engineering in the healthcare sector is really time consuming. So therefore now we are currently shifting from manual to automations and robotics, whereby we automate workflows, which in time will streamline processes and remove a lot of bottlenecks in biomedical engineering and in the healthcare industry. So currently, it's being
Sorry to come in, Mr. Boateng, please. Kindly admit new participants. There are some of our members on the waiting room. Thank you, sir.
Okay. Thank you, sir. Is it okay?
Yeah, thank you, sir.
Okay. So, as I was saying, running a healthcare industry now involves numerous workflows. To repeat myself, such as the case management, patient wellness, remote monitoring, and a whole lot. So manually managing all these workflows in biomedical engineering, specifically in the healthcare, is really time consuming. And therefore, there's the need for us to automate all these workflows, able for us to streamline processes. By that, we are able to remove a lot of bottlenecks in the health industry. So currently, by the Scalar research, it has been seen that by 2025, the amount of revenue that will be sourced or gotten from automations and robotics in biomedical engineering or the healthcare is over $15 billion. That's the revenue that we'll be getting from automating all our processes. So currently, the healthcare or biomedical engineering is gradually shifting from manual to automations and robotics. So that's where we are heading towards now as biomedical engineers. We are shifting from manually doing things to automating our workflows. Hello?
Hello, I can hear you.
Please, my slide is not moving. Please, which slide am I?
You are still in the first slide. Or
I'm on the third slide.
the past is not moving. Okay, maybe you can stop and reshare. Meanwhile, you can see if you can admit new people who just joined the meeting. You can stop and reshare this slide and also try to admit new people. Yeah. So maybe every time you have to check and admit new participants, maybe per slide.
Is it okay? Are you okay now?
Yeah, we can see you.
Yes, sir.
Yeah.
Okay, please, so I will now touch on the definition of robotics and automations. So robotics involves the use of softwares. It involves the use of sensors, advanced technologies to enable robots to perceive, reason, and also act in the physical world. So when we talk about robotics, is the use of softwares, computer instructions using sensors, advanced technologies, able to for the robots to perceive, reason, and also act in the physical world. So that's the definition for robotics. And also for automation involves the use of mostly with the application softwares, AI powered tools through machine learning, able to make or to streamline and make processes efficiently. So that are the two major difference between robotics and automation. The robotics deals with the physical hardware, okay, the sensors, the feedback systems, and the electronic aspects. That's the robotics. But the automation itself regards the software technologies, okay, the AI tools that will be used to streamline or enhance the processes. So that's the difference between the robotics and automations. I would like to touch on Now let's start the application of the robotics and automations in biomedical engineering. First of all, I would like to chat on the surgical assistance. Surgical assistance.
Sir Eric, please, I think we have a little technical challenge that maybe every time you need to let in new members. We are sorry for these conveniences on you. I think we should have made it. We'll make a better arrangement next time. So please allow new participants to come in because they are writing out that they can't come in. So maybe every slide or every 5 minutes.
Is it okay?
Yeah, I think it's okay. So like every 5 minutes or every slide, you check to allow new ones to enter. Maybe every 5 minutes.
Sir.
Yeah, thank you.
Okay, sir.
Thank you.
Okay, so first of the applications of robotics and automations in biomedical engineering is one for surgical assistance. Robotic assistant surgery normally involves three compartments. One, you need a console. Okay. Two, you need a patient side cart. And three, you need a 3D vision system. So the console is where the surgeon sits, okay, to maneuver, the processes. Okay, it's like a console where, like, with a joystick and other maneuvering systems, whereby the surgeon will sit and control the surgery processes. So that's the console. And secondly, for a surgical assistant, you need a patient side cart. The patient side cart normally is the arms. Normally, it can be 3 arms or 4 arms, which holds the surgical instrument, okay, for the operation or for the surgical processes. And secondly, you need a 3D vision system. So the 3D vision system will magnify the view for the surgical operation to go on smoothly. Currently, robotic assistant surgery reduces post-operative complications by research by 50%. It also helps reduce blood loss, and also it helps patients to be discharged early in the hospital. So these are the main importance of robotic assistant surgery. It helps to reduce post-operative complications by a very huge percent. It's able to reduce loss of blood as compared to manually operating, thereby enhancing efficiency of the surgery. So one of the main applications for robotics and automations is the surgical assistant surgery. Second of the applications of robotics and automations in biomedical engineering is that robotics is used in hospital hygiene. As you can see an ultraviolet ray machine, robotic machine, which is able to sterilize theater rooms. It can be used to sterilize the wards and other rooms in the hospital. So this, as you can see, is unlike the manual way of using disinfectants in the hospital, spraying and all that. This system uses an ultraviolet rays to disinfect. It moves around the room to disinfect the place. So one of the applications of robotics and automations is that it's used in hospital hygiene. Third of the applications of robotics and automations is rehabilitation robotics. Normally during let's say when a patient has gone through maybe surgical operations, or maybe has had is having neurological diseases, like let's say after amputations, or had some let's say, some bottlenecks in the biomechanics system of patients. Rehabilitation robotics have made it to a state that is able to train instead of the manual going to a physiotherapist to go for a manual training of your arms, like lifting of your arms, training and all that. This rehabilitation robotics is able to train you. It's able to rehabilitate you. It has sensors and all that to able to revive you to come back to your normal state. So this we have some coming as robotic wheelchairs, some coming as closed loop systems, able to help us to rehabilitate our patients. Fifth on the list is soft robotics. Soft robotics means that we use either natural or synthetic materials to streamline the healing process of patients. For example, is let's say those that have gone to let's say have an upper limb prosthetics or lower limb prosthetics. All these prosthetics use soft robotics, and at the end they have to be controlled using control programs and all that. So one aspect of the application of robotics and automations is soft robotics to augment the limbs of patients. It also involves another application of robotics and automations is that is used in test tools or test devices. These test devices are normally either they are mechanically inclined, they are pneumatically inclined, electronically inclined. So normally in biomedical engineering, we use these test tools for calibrations, for functionality tests, performance tests, and verification tests. So, for example, we have let's say we have pumps, we have test pumps, for example, to make sure that some parts or functions of our biomedical equipment are within range. They are within range. They are within some tolerance and deviations, that they don't fall apart certain deviations and tolerances. So one way of applying biomedical robotics automations is through our test devices that are used in our field. As biomedical engineers, we use them in our day-to-day activities. Another application of automations and robotics is telemedicine. Sometimes patients can't be going to see their physician on a daily basis. So through automations and robotics, patients can sit comfortably in their home and have a chat or have a consultation times with their physician. So through that, all this process uses AI tools, vision tools to streamline consultancy. So another way of applying automations in biomedical engineering in the healthcare sector is through telemedicine. Thank you. Also, let me touch on the medical delivery robots. Now we have robots that can deliver, let's say, vaccines, can deliver whole bloods, can deliver medical consumables intra hospitals and even inter medical facilities. So one way that robotics and automations are applied in biomedical engineering is through medical delivery robots, whereby medical staffs are able to transported between two a medical point. So all these applications of robotics and automation in biomedical engineering. I would also touch on robotics in medical manufacturing. Most importantly, we cannot be in the biomedical engineering field without manufacturing. Of course, our medical systems, our healthcare system are manufactured. They all go through manufacturing processes. So this is the most important one. Robotics in medical manufacturing. Almost all our machines, being the healthcare systems, pass through all this process to streamline and also make manufacturing, faster and efficient. So that's it. Robotics in medical manufacturing. It also include manufacturing of medical parts, medical consumables, and in units, and also other pharmaceutical components that's being used through automations and robotics. I'll also touch one aspect of the applications of medical automations and robotics is through medical waste management. Is also applied. Robotics and automations are applied in medical waste management. As you can see, I think I went to work on this ECODAS, a waste management system, which uses a microwave to heat and sterilize a medical waste and shred them into pieces for a disposal. So all these processes uses automations and robotic systems. So as I'm saying, robotics and automations are also applied in biomedical engineering in the medical waste management system. One way also that robotics and automations are applied in biomedical engineering is for drug prescription and dispensing. Normally used in the pharmaceutical industries, we've been able to build drug prescription and delivery systems whereby everything is automated through set of instructions. For robots to work, one, you need three things. You need power, you need program of instructions, and also you need a control system to actuate your instructions. So this machine here has been embedded with instructions and tools to prescribe drugs for our patients. So thereby automations and robotics in prescription and the dispensing system in biomedical engineering field. So all these processes work on automations and to make drug dispensing efficient and to remove all bottlenecks in the pharmacy industry. I'll also touch on nanotechnology. So as biomedical engineers, I know we normally work a lot with biosensors. We normally work a lot with biosensors, and during the manufacturing of biosensors and biovalves and all that, these tools, biomaterials, also you need an element of robotics in its manufacturing, sequencing and all that. So all these systems for nanotechnology uses the cause of robotics and automations. Most importantly of the applications of robotics and automations is a diagnostic system. It can be in vitro or in vivo, or from radiology to a clinical laboratory to therapeutic healthcare systems now are being automated. A clinical example is our chemistry machine. I think we all know the chemistry machine it works on the process of automations and robotics. Even in our most modern imaging equipments that are used for diagnostics also uses the elements of automations and robotics. So ideally, most importantly, one aspect that has really made strides in automations and robotics in healthcare is the diagnostic sector. Has really applied the principles and concepts of automations and robotics in all aspects. Advantages of robotics and automations in biomedical engineering. One is progressively moderate treatment. As we see, as I told you earlier, in respect of the robotic assistant surgery, it reduces post-operative complications by a huge number of, like, let's say 50%. It's able to reduce blood loss, and also it helps in early discharge in the hospital. So for robotics and automations, it's progressively moderate treatment. Secondly is reduce operator time. Since processes are faster and efficient, it's able to reduce time. You doing it manually, you doing your sequences or your procedures manually takes a lot of time. So automations and robotics has come to streamline the process and also remove a lot of bottlenecks in biomedical engineering field. Secondly, more patients can be treated because of the system is being automated. Okay, you'll be able to treat a lot number of patients, and also you can run a lot of samples if it's clinical diagnostics. Yeah, so one, you're able to increase your throughput. Let's say, for example, manually running a machine can take maybe 3 hours to do, let's say, 10 patients. But if you automate your system, you can run a lot more than you manually doing it. And also is improve quality. Automations and robotics have really improved quality in biomedical engineering. Yes, because it's less danger, and you remove a lot of human errors in automations and robotics. So these are the few advantages that I can say regarding automations and robotics. One, you can really progressively and moderate treatment. You reduce operator time, more patients can be treated, and less danger, and also it improves the quality of our workflows. So I'll conclude by letting you know that robotics and automations is not doesn't come by chance. It doesn't come by air, like from the skies. We really need a lot of research. Okay, as the years goes by, research going on every day. So in order to improve our workflows in biomedical engineering, we really need to have an in-depth and constant research that will help develop a sense of automations and robotics in biomedical engineering. So I would like to end my presentation. If any questions, we can go on. Thank you for having me.
Wow, thank you so much, our distinguished speaker, for that insightful presentation. So please, if you have any question or comment, kindly signify by raising your hand. Thank you. Okay, we have a question in the chat box.
Please,
How do we handle?
Can you take over maybe to allow more members if there is anybody that is still hanging?
Okay, so please, you
think-
can make me the host now.
Maybe you can transfer.
You can transfer the host to me, Mr. Boateng. Thank you, sir. So we have a question here. How do we handle the approach of robotics in Africa? As a treatment aid, quite a number of clinics still have doubt, hereby preferring the old way medicine. As much as we biomedical engineers try improving the devices, we need end users for proper improvements. So that's a question from one of the participants. Over to you, Mr. Boateng.
Please, the question again.
Question says, how do we handle the approach of robotics in Africa? As a treatment aid, quite a number of clinics still have doubt, hereby preferring the old way medicine. So as much as we biomedical engineers try improving the devices, we need end users for proper improvement. So that's the question. How do we handle the approach of robotics in Africa? You know, Africans have some mentality. I think that's what the participant is trying to pass across.
Okay, so if I understand, we can sensitize robotics and automations by one through sensitizing. Okay, as you are saying, most of the medical staffs are used to the old ways of doing things. So first of all, we have to sensitize them. We have to let them know the importance or the advantages of robotics and automations, whilst still maintaining patient quality or patient outcomes. Okay, some of the medical folks think that if you bring in robotics, you would manipulate the outcomes of patients. Okay, but we have to let them know that no, robotics automations have come to stay and also to improve healthcare. So one way of improving healthcare in Africa is through sensitization, through education. And I think through the proper education and sensitization, we can able to streamline robotics and automations in Africa. That's how I understand.
Okay, thank you so much, sir. Mr. St. Matthew, I think you have a question. Can you go ahead, please?
The hosting rights has been transferred.
No, please kindly transfer the host.
Okay, please, can you confirm if I'm audible?
Yes, please continue.
All right, thank you. My question is, as a biomedical engineers, speaking of one advantage of the robotics and automation in BME, Mr. Boateng highlighted less danger, that is less human error. So how do we convince other medical practitioners and patients of if we are going to have less human error, but this can also, this less human error can also prone us to more equipment error, since the devices will be doing more of the old diagnosis and everything. So how do we convince our end users and also other medical practitioners on the effectiveness? Yeah, I think that's the question. On the effectiveness of this robotics in automation when it comes to diagnosis and aiding treatment of patients.
Over to you, sir, Mr. Boateng. Thank you for your question.
So if I could hear you, you are saying how we can convince the medical staffs on why they should use the robotic systems? Is that a question, please?
Yes. Instead of the traditional means, or let me say former means of diagnosis and treatment.
Okay. if I could answer your question, robotics and automations does not mean that there will be no human, there will be no any human factor. Okay. For example, the robotic assisted surgery, as you said, as I said, you need a console. So the surgery will sit behind the console to do the manipulations. Okay, so robotics and automations does not mean we have completely removed the human factor. You let me come on the diagnostics aspect that you are saying. We have a machine called a NemoDX96, which is used for an infectious disease diagnosis. It works solely on automations and robotics. And this is what happened. One, the user has to feed. Let's say your chemicals, your chemicals, let's say your reactants. You have to feed in the system. So robotics automation does not mean that you are removing completely the human factor. The human factor will do the input. You do the input, and the rest you leave it for the machine to do its computations and all that. And we have to let them know that one, automation robotics would increase efficiency, and also two, it will increase the number of tests. The number of tests that can be run. Bear in mind, this is the healthcare industry, and agency really matters a lot. So we can't wait for the manual computations any longer. The patient need the results right there and then. We don't have time for mixing chemicals and all that, waiting for results and all that. This time, automations does everything. For example, the PCR machine, okay, it does everything. Within a few minutes, you can handle a lot of patient samples. So we first have to let them know that robotics and automation does not completely remove the human factor. It still has a human factor, but automations and robotics came in to help streamline medical diagnostics by one, efficiency, two, to increase the throughput, that's the number of patients or samples that you can run. So it's all about sensitizing them and we proving that actually automations and robotics is the best now. And now healthcare is shifting from manually to automation workflows. So I think we should let them know the advantages of automations, and I think we would come up. Sure.
Thank you so much, Mr. Eric. Is there any other question? Mr. Matthew, are you satisfied with the answer, please? Because I can see your hand is still up.
Yeah, I have another question for Mr. Boateng.
You have another question? Okay, please go ahead. Thank you.
All right. Okay, I don't know if I'm putting this the right way, but sir, being an advocate, I think that's the word I can use best for robotics and and automation in biomedical engineering. Being an advocate for something like this in the engineering sector, in the medical engineering sector, what platform would you recommend, or what platform are you spearheading to enhance upcoming biomedical engineers and medical practitioners to get this knowledge that we need to to launch the medical diagnosis service into a new advanced level? So what platform or do you recommend, or do you have connections or access to that you can recommend for upcoming biomedical engineers that would like to grab more knowledge and delve into this particular part of biomedical engineering? Thank you.
Thank you for that question, Mr. Matthew. Over to you, Mr. Eric.
Hello, sir. Platforms.
Mr. Eric.
Hello.
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 Go ahead, we can hear you.
So, hello.
Hello, Mr. Eric.
Go
Please
ahead,
go
please.
ahead.
So we have medical. We have medical manufacturers. Okay, like Kaizen. Okay, when it comes to the clinical diagnostics, one of the manufacturers that even I had my training. I had my training with Kaizen in Turkey, and they are manufacturers of clinical laboratories, clinical laboratory systems. So this when you really need an in-depth, let's say when you are a biomedical engineer and you really need an in-depth for robotics systems training, the best avenue is for you to see the OEMs, the original equipment manufacturer. Without they training you on their healthcare systems, you're not able to work on them. So one way of we being adapt to this robotics in our in this robotics medical healthcare systems is to liaise with the OEMs, the original equipment manufacturers. They will give you permission to their platforms, train you, then you can work on their healthcare system. So it's up to us to find out which medical system that we want to work on. We meet with them, or we liaise with them. They give us opportunity to work on their platforms. Then we move from there. So I think without this medical manufacturers giving us their platforms, we can work on their systems. So it's about us liaising with the OEMs. They give us training on their platforms, then we take it out from there. Yes, that's all I answer this question.
Okay, thank you so much, sir. Mr. Emmanuel, over to you, please.
Yeah, Mr. Eric, thank you very much for your presentation. I have a little contributions and also a question. My contribution with respect to how we can convince people to accept the use of robotic use of automations in biomedical engineering. I think, to me, we are Africans, and there is no amount of preaching you will preach to somebody who is ignorant of something for the person to be aware. There is no amount of preaching you're willing to preach. So I believe the best way is we have regulatory agencies in our country, various countries rather. The moment the manufacturer of any device or of any program or something relating to this automation prove beyond reasonable doubt via clinical trials that the device is effective, I think those regulatory agencies, the moment they approve it and is into the market, I think there should be no fear for anybody to use it or thereabouts. That is
sure,
what I think.
Definitely. And let me add this, because the cost, I think one of the things that is really hindering robotics and automations in our healthcare system in Africa is the cost of the healthcare systems or the equipment. Robotics machines are very, very expensive. Some go as far as even cost at $500,000, $300,000. So one of the reasons why robotics and automations is not thriving in our clinical setting, I think, is the cost. The cost really involved in automating in our healthcare is very, very expensive. And we Africa, I think we are getting there. We are really getting there, but it won't be now. But slowly but sure, as we get financial support and all that stuff from people, we would be able to read there. So without we having the financial base to bring in all these robotic systems, we will still be there, down there. So I think we really need to open our arms widely, work hard to be able to meet that kind of this one. Yeah.
I agree with you with the cost. Why the cost is also an issue. There is also a fundamental problem within our political space in Africa. Now,
Sure.
for instance, every government, because you cannot take away politics from at times launching of devices or accepting of technology. You cannot take away politics from it because, for instance, every government wants to create job, but you come in, you bring in a device that will create unemployment. For instance, that would reduce the numbers of people that these politicians will boast that we employed this amount of people. I mean,
Sure.
he doesn't want to accept it, despite knowing that this thing is effective, is good, but it's going to create unemployment. In the midst
Sure.
of unemployment, of course, we have huge unemployment. Bringing technology that will create unemployment again, I think is also another problem or another source of concern for most of the political groups within our various countries. So that is another hindrance which I think maybe
Exactly.
time
Exactly.
we need to figure it out and
Sure.
maneuver it.
Exactly.
Then
Exactly.
my other question to you, is, most of us seated here, we are biomedical engineers. Just like the question somebody asked, which I can't actually remember vividly what the languages he used. Or as an engineer, I'm interested in knowing how can I start a little laboratory prototype of an automated device. How do I start it? Like, I'm interested because we need to start from a step.
Sure.
How do I start it? What are some of the things I will need? What are some of the working principles? How do I go about it? Like, a student might be interested right away. He wants to delve into automation in biomedical engineering. How does the student start? Please, could you, Engineer Uduma?
Yes,
Udumala, could you please help mute? Yeah, thank you.
Mr. Eric, kindly unmute yourself. I've muted everyone. I've muted all participants.
Okay. Okay. Thank you. Thank you, sir. Please, can I go on?
Yes, please go on.
Okay. So the type order I would like to answer your question. The type of automated system that you want to build will depend upon the function or the results that you want to achieve. Let's say what you want to achieve in diagnostics will be different from what you want to achieve in, let's say, in therapeutic. What you want to achieve in therapeutic is different from what you want to achieve in, let's say, rehabilitation. So first of all, if you want to build, let's say, a mini automation or robotics device, first of all, you have to know what function or what do you want to achieve. Yes, then we take it. Then you take it from there. Secondly, you need your materials. Which materials do you need in able to achieve your aim or function? Okay. Secondly, you need a software if you want to advance. What kind of a set of instructions or, let's say, software application are you going to use? Thirdly, you have to know your power. What kind of power are you going to use? Are you going to use DC or AC or whatever? Thirdly, you need to control every automation system or every robotic system needs a control system. Okay, needs a control system to actuate your instructions. That's your software, because you need control systems able to work on your. So these are the 5 things. First of all, you have to know the function or the goal you want to achieve. You also have to get your materials. Which materials you want to use? Do you want to use soft materials? Do you want to use plastics? Do you want to use natural stuff? Thirdly, you need a software or a program of instructions, because without software or program of instructions, you can't automate your system. And thirdly, you need a control system. What do you need? Actuators? Do you use do you need sensors? Do you need biosensors? Do you need let's say pneumatics? So all these things are very, very important when you want to build a robotic and automation system. So it all depends on what you want to achieve and later. Oh yes, so that's how I can answer the question.
Thank you so much, Mr. Eric. Mr. Obala, over to you, please. Mr. Obala Aruna, over to you.
Good day, everyone in this platform.
Good day, sir.
Please, my own is only I need the second slide of the second slide, because when he's giving the presentation, there are points that we not pick up. So I need the second slide so that the point I want to get from the slide. Thank you.
Okay, so if you were here at the beginning, I made an announcement that the recording will be made available on our YouTube channel. That's Nsbce Media. So after the webinar, you're going to get a recording of the webinar. Thank you. I think there's a question here on the chat box. Thank you for sharing, sir. For the OEMs, how can I get started as a student with little experience in getting practical experiences with them?
Come again, please. Come again, please.
Okay, he said, thank you for sharing, sir. For the OEMs, how can I get started as a student with little experience in getting practical experiences with them? That is, how can he get practical experience with the OEM as a student?
Okay, so as a student with a little or no, let's say much working experience, for the OEMs, they first of all, they have to see your competency. Okay, the OEMs does not train in vacuums. First of all, you have to meet their let's say their training itinerary. One, are you competent? Your experience wise, because they have to train someone who they believe in, because at the end you are representing them. Yes, you are representing them in your country or in your this one continent. So first of all, you have to pass the competency test, because this is a life-saving equipment. Okay, whether diagnostic or therapeutic, it's a life-saving equipment, and you have to pass the competency test. When you pass the competency test, because every training with the OEMs, you have to write an exams, able to qualify you to go for the training. And after the training too, you write a test. If you fail the test, you won't be given certifications to work on the machine. So first of all, before you go for an OEM training, one, you have to they have itineraries that education-wise, your experience. Sometimes some companies don't really matter about the experience; they matter about your let's say your education. It all depends on the level of complexity of the machine. Yes, OEMs don't do training in vacuum. Before they train you, they check on the level of complexity of the machine, whether you are experienced, can you work on it, your educational background. So you have to also examine yourself that, hey, this kind of healthcare system that I would like to train on, can I work on it alone when I'm given a chance? Can I work on it alone? Do I need support from my other colleagues and others? So you can always write to them. You can always they are all over. You can go to their a website, charge them that you want to be trained on the machine and all that. So they will give you some series of itineraries. If you pass it, they will allow you entry. You do your visa processes and you go for the training. So it all depends on how competent and experienced you are, and the belief that you have in yourself. Then their doors are always open. So you have to also do your homework well, making sure that you are well versed in what you want to go to do. You have passion of what you want to do or work on. So for them, their arms are always open. It's up to us that are we really qualified? Do we fit in their itineraries to be trained and all that? So that's all that I can say. Yeah.
Thank you so much, sir. Mr. Nu, over to you, sir, please. Mr. Nu. Mr. Nuhu, are you with us?
Yes, thank you very much, sir, for this wonderful presentation. I just have a question in general for automation processes, and we have a lot of amazing individuals that are actually emerging in terms of automating processes in the healthcare sector. But my
Sure.
question is, do we have a centralized, will I say, regulating body that oversees the ethical considerations to all automated process, to companies and even individuals that would like to provide solutions